Hello everybody, my name is Arul Kolla. I am a 2023 Caroline D. Bradley Scholar, and today I will be talking about the second video in my series on creative problem solving. Today we're going to be talking about changing your point of view. So these types of problems are sort of like unusual types of problems that you might see when you're doing creative problem solving. So again, we will get into all of the details shortly. But first, I'd like to give a brief overview of what creative problem solving is, just for those of you who don't know. So it seems that everyone's always talking about creative problem solving, right? We see it everywhere in like books and school papers and like applications and everything. But what is creative problem solving? So here is a few definitions that I've made that describe what the difference is between an exercise and a problem. So an exercise is a task in which you already know how to solve. So you've seen something else kind of similar before, or you already know what to do. So think of like a regular math worksheet in school, where like, for example, you are taught how to do like say addition in school, and then for homework you have to do 20 more additions. That's an exercise. But a problem is where you don't know what to do, and you need to be creative or original. This is the key idea of creative problem solving, is the second topic of solving problems more than exercises. And the goal of solving creative problems is that we want to teach new and exciting concepts, right? We don't want to teach the same way to do the same thing. We want to teach new concepts that you haven't seen before. And so that's our goal when we're trying to go on this journey together through creative problem solving. And lots of people think that creative problem solving comes naturally, but in fact, creative problem solving, you should be learning it by itself. Creative problem solving is itself a skill because it's very complicated in and of itself. It has lots of topics, lots of detail, and lots of depth. And so that's why I think just treating it as like a group of topics is not really giving it justice. So let's talk about thinking from a different point of view. So sometimes when you start working on a problem, you make assumptions about how to approach it, right? This happens all the time. When we start working on a problem, we always have something that we're already thinking about, right? We like read the problem and we're thinking, okay, we have to do X to get the answer of Y. But sometimes if we can't find the answer, this doesn't mean that our our Y is wrong. It might mean that our X, the thing that we thought about, was wrong. And so this is the key idea of changing your point of view. Because it's often that we get stuck on these types of problems, right? If you have a certain like fixed mindset, it's really hard to sort of go back and change the mindset there, right? Like it's really hard to go back and say, okay, well, I know that this is not working, so I have to go back and change it. And this a lot of people have trouble with. So that's what I'm going to try and explain today. And especially in creative problem solving, where you need to be creative. And being creative is not easy, right? If everyone is creative, the world will probably be much better. But in creative problem solving, it can sometimes be helpful to stop and look back at how to approach the question. So a lot of the times we just get stuck in this loop of keep on like approaching the question, not getting it, and approaching in the exact same way. So if we stop and look back, then we may have a different idea of different ways to approach the question. So let's take a look at this sample problem. So it says, it costs 2 cents to open a link and 3 cents to close a link. And we have the 4 chains on the left. Can you make the bracelet on the right with only 15 cents? All right, so hopefully you had time to pause the video. So let's take a look at how to approach this. Well, first of all, let's do a sort of naive approach, right? So there's the picture again. So we have this sort of 3 links, right? And we want to make this sort of ring of, ring of links. So what we can our first idea, our naive idea might be, right, take this link, this end link over here, and connect it to the beginning of this link. And so you get a longer chain, right, of 6. Then connect that 6 to the 9 to the other 3 to get 9, and connect that chain of 9 to get 12. But let's see how much that costs, right? So this is an alternate way to view it. We can arrange them into a square, right, and open and close the 4 corners. So you can see we'll open this link, this link, this link, and this link, and we'll close all of them. So remember, opening is 2 cents and closing is 3 cents. So to open and close, that is 5 cents. So if we open and close each of the 4 corners, that's 5 times 4, that's 20 cents. And lots of people have tried different variations on this, right? Besides the square version, you can try, again, like I said, connecting into a long chain and try and make a bracelet from there. And these are often assumptions people make, right? This costs 20 cents, so we have to change our point of view somehow, right? So this is the hard part, is first of all, recognizing that you're making some assumption. Because a lot of people, when they try a lot on a problem, they'll just give up. But it doesn't have to be that you just don't, quote unquote, get the problem. It could be that you're just making some assumption. And so let's see what assumption we could be making. So again, yeah, we need to change our point of view, but how can we do it? We don't really know. So that's the whole point of creative problem solving, right? How are we going to change our point of view? Well, one thing that we may think about is that all throughout our process of thinking, we're trying to keep these chains connected, right? Like we're not like completely breaking up a chain. We're taking one chain, then connecting another chain, connecting another chain, and connecting another chain. So we're treating these chains as sort of units, right? We're not going to like destroy the chains completely and then link them back together, right? What we're doing is we're sort of treating the chain as like a solid thing that we can't break. So this is a weird assumption that we're making, right? Because does that always have to be true? So what happens if we don't make this assumption? You can pause if you want now, because this might be a good time to try and think about, like, what if we didn't break the chain into its links? What if we did break the chain into its links, sorry? Because right now we're trying to keep the chains connected so we can connect chains on top of chains on top of chains. But what if we don't? And what if we break the links apart? What'll happen then? So you can pause the video if you want. All right, so hopefully you had time to think about that. So here is the solution. So what did we do here, right? So first of all, what did we do is we just broke up one single group of 3. We just broke it up into 3 smaller parts and then connected those 3 links here, here, and here, and we made our bracelet. Now you can see that this solution broke the assumption that we made, right? Because before we were always thinking like, okay, we got to keep these chains together, but we got to stack the chains or something, right? So this is the assumption we need to break. And this is a very common theme, is that this sort of solution is very obvious once you see it. But the thing is, it's hard to come up with unless you realize that you're making some assumption. And so that's why it's really important to, if you're having trouble on a problem, maybe step back and see, what are you thinking about? That's like, what are you trying, right? This problem is just about trying things and see if they work. So what are you thinking about that might not lead you to the solution? So let's do another example. So this example says, put 10 trees in 5 rows with 4 trees in each row. So you can pause the video if you want to try this. All right, so this seems impossible, right? We have 5 rows and 4 trees in each. So that's 20 trees. That's way too many trees. How can we put 10 trees? Well, the idea that we're having is that rows must be like on top of each other, and rows don't have to intersect. Now, this is a lot, some people have a little bit of like, some people argue a little bit about what the definition of a row is. Some people say a row is just like one part of a grid, like each horizontal line in a grid. But in this case, if we have rows of trees, all the rows don't have to be like parallel, right? You can have one row like this, and another row like this, another row like this. You can have lots of different rows. And so there are half as many trees as there should be, right? There quote unquote should be 20 trees, but we only have 10. So this means that the rows have to overlap somehow, right? which means that some trees have to be in 2 rows. And so now, again, if you want to try and pause and see if you can solve the problem with this information, right? The idea that the rows have to intersect in some way. And this leads us to the solution. Now, I know the solution is a bit hard to think of, but still, it's much better than, say, trying to think of it without the idea that the rows must overlap. Now you can see all of the rows, 1, 2, 3, 4, 5, all of the rows overlap with every other row, right? We can see that if you pick 2 different rows, there will always be a tree at their intersection. And so this is the solution. And you can see the 5 rows, the 4 trees. So the idea here is, again, we're trying to think of a way to escape our idea of what the word row means, right? We're trying to get out of this mindset that we have of what is a row and what isn't a row. All right, so here are a couple takeaways from this lesson. First thing to think about is, what are we making an assumption about? What are we thinking about before we even start solving the problem that might hurt our chances of actually doing it? So this is a good question to ask yourself, especially when you've been spending a lot of time working on a problem, is what are you going to make an assumption about? And experimentation. Even if you know the correct way to assume, experimentation is very important, because these problems, it's a lot of trial and error, and sometimes you need to be really clever to get the answer. But you can't be clever if you don't try. So experiment, just try random stuff. Who knows, it might work. And yeah, like I said, these problems are hard, so don't feel like bad if you can't get them, because again, lots of problems even the world's best problem solvers can't solve. So creative problem solving is not about getting every answer correct every time. It's about learning, so you grow these skills as a person. And for a final challenge, if you want to try this out and post your answer in the comments below, we have a problem here. Place 33 sheep in 4 pens, so each pen has an odd number of sheep. And each sheep must be in a pen. So again, this one you sort of have to think outside the box, or rather outside the pen. And yeah, try this one. If you have any ideas, you can post your solutions. But for me, that wraps it up. So thank you again for joining me. My name is Arul Kolla, and I also make creative problem solving games. My latest release is currently called Blocks. You can see it at blocks-ak.web.app. But other than that, thank you very much for coming, and I hope you enjoyed this virtual learning lab on creative problem solving 2, changing your point of view. Thank you.